Okay, so in continuation with your B plus tree, and we were covering the examples. Uh, in the last example, we saw that, and we took the values of block pointer, that is 9 byte, and record pointer as 9 byte again, means the same value, right? So remember, if your size, see this question generally they used to ask in a multiple choice question, and it is being asked also. So if the size of your block pointer is equals to the size of your record pointer, that is what here, right? So then what will happen? Then your order of B plus tree leaf node will be equal to what? Order of your B plus tree internal node. Remember, same order will be there, right? So let's understand, I mean, let's take the values and we'll see, understand how the same values, the same order is coming. Okay, so block pointer value is 9 byte, right, in this example, and the block size is value 512 byte. The key value is your 10 byte. The question says that your order P is what? See, these questions are very important. Again and between, again, I'm just saying because these questions are very, very much asked, right? So definitely have a practice. If order P is the maximum possible key that can store in your B plus tree, right? So that can be stored in B plus tree. So it says what is the possible order of B tree node, right? So what is possible order of B plus tree node? That definitely we need to check internal node as well as leaf node, right? So for internal, what should be the formula? We have key, for key we have, that is what in internal node we have only key values, not the record pointer. So that is what P times key, we have the key value, plus it should be P minus 1 times block pointer, isn't it? Right. So it says P minus 1 times block pointer plus P times key less than equal to size block, that is 512. Right. We put the values. P minus 1 times block pointer is 9 plus P times 10, that is 10 less than equal to 512. So if you will solve, you will get the value of P is 26 point something. So that is 26 value over here. Right. Now for your what leaf node, let's check for your leaf node. So for leaf node, what how many block pointer we have? Exactly one. That is one. We have the key as well as record pointer. So add both them. How many? P minus 1. We have understood. Right. So formula is block pointer plus P minus 1, key plus record pointer values less than equal to 512. And you solve for value of P over here. You will again get 26 point something. That is 26. So put the values and get the result is 26. Right, so see both of the values is same. So that's why when we have the same size of block pointer and your record pointer, we have the same um, order values. Right, okay. This is what we have understood. Now let's see a different type of question, which is also another very, frequently asked most of the time. So what they say is that you need to find either minimum or maximum keys in either B or B plus tree for given L levels. So they will ask you for levels or say the H height. Remember, given height and order P. This is what you will be given. So see this question again. Let's see. You need to think how to solve and how you will reach to the answer for this such type of question. Right. So question like how many maximum keys in B or B plus tree with, say, order P is 5 and level, or say the height level is 4. The question will also say that you need to assume the order P is what? The maximum possible block pointers. So this must be given. Question is incomplete without this information of order. That is maximum possible block pointers per node. Remember, right? So let's just try to understand actually what this question is saying, right? And what we actually need to do. It says that the order is 4 and the level is, order is 5, right? So order is 5 and for order says the maximum possible block pointer means you can have maximum 5 block pointer, 1, 2, 3, 4 and 1, 5. Then how many keys? These are the block pointers, means the child. 5. How many keys? 1, 2, 3, 4. That is we have understood. So 5 order means 5 minus 1, 4 key value can have, right? So question says how many maximum keys. So these how many maximum keys in B or B plus tree? See both, because answer will be different in both. See how the level of difficulty, or say the question is B plus tree with order P is 5 and level 4 means 4 level. So again we'll have some values over here, right? In this way we'll have this, again we'll have this one with every node in this way. You can just visualize, right? And so on. This is 1, 2, 3 and another 4 level. So you can assume. So for this all, how many maximum keys are possible in this case? And even they can ask you how many minimum keys are possible. So four type of different type of questions can be here, right? With the maximum, they can ask you in B and B plus maximum key, and with minimum key, they can ask you in B and B plus tree. So see four possibilities for different answers they can ask you over here, right? Okay, let's just try to solve this here. In this level, how many block pointer we have? 5. Right. Here, how many block pointer will be there in the second level here? See, with the 5, we have different 5 nodes, right? So 5 node will be there. And in every node, how many record pointer will be there? That is what? 5 minus 1, isn't it? So that is 4. So we'll have 20 block pointers at this level. 20 block pointer at this level means in the next level we'll have 20 nodes, because as many block, because in first we have 5 block pointers, so in this another level we have 5 nodes, that is 5, and each node we have 4 key pointer. In the next one we have 20 nodes, and then how many we have, again how many record pointers will be there, and in the same way the next one, and so on, right? So this is the one rough visualization, or say how what the question is asking from you, right? But obviously we cannot solve such type of questions in this way, right? So what is the way and how we solve such type of questions? See, solving these questions only you understand. Question is visible, yeah. Okay, so what we'll do is we'll make a table and let's see how we solve the question here. What we want, we will compute for different levels over here, right? So we'll see different level, and what we want, we find out what is the maximum node at each level we have, right? The question asks for the maximum, right? So we can go for minimum as well. So the question is for maximum, so at every level we'll find what the maximum nodes we have, then we find out what is the maximum block pointer, right? And also we find out maximum what keys. This is what information we need to find out actually. right? So if we compute all the values, probably the question will be over, right? Okay, now let's start from very first level. So what is the maximum node that we can have in the first level? So obviously we know that in any, let me just take a rough page also. Yeah. See, any tree we construct, right? And even we have seen when we are just continuing the indexing, I told you we will perform multi-level indexing till the last whenever we have a single block, right? Single block means a single node. Till that we do multi-level indexing. That is what the minimum condition, right? So always remember. So what I mean to say is always in any tree we have, one as a maximum or even one as a minimum node also, right? That will not change. So now maximum block pointer, right? So in the question, now move on to the question, how many block pointer, maximum block pointer we can have? 5. Yes or no? So P is the maximum possible block pointer. That is P is 5 given, right? So you write 5 here. Then what will be the maximum number of key at the first level? If we have 5 pointer, block pointer, then how many keys? 5 minus 1. That is what? 4. This is what we have finished level 1, right? So far understood, easy. Moving on to the second level. So in second level, how many see the maximum node that we can have in the second level, that is equals to your maximum block pointer in your first level, isn't it? We understood here, right? So the as many number of block pointer in the first level equals to as many nodes in the second level. So you can just write here, we'll form a pattern. So this 5 will come here, right? So if we have 5 maximum node, then how many maximum block pointers we can have, right? So for 5 node, and we also know P is what maximum block pointer, and that is what 5 only, right? So for 5 node, 5 block pointer, that is your maximum block pointers we have, right? So don't confuse why I didn't write 4 over here. Obviously it should be 5, right? Because the order is given 5. 4 is the maximum key, and 5 node we have, in every node contains 5 block pointer, so maximum block pointer 5 times 5, right? So this question can come in your mind. Okay, then maximum keys, again how many nodes? 5. And now what is the size or say many keys in a single node? That is 4, right? So this is what we have finished level 2. Now level 3. For level 3, how many nodes? Again the maximum block pointer that we have in the above level 2, that is what 5 times 5 means 25, right over here, right? The same value. Now, what is maximum block pointer? Same, 25 node we have in a single, how many we have? 5 block pointer, that is 25 times 5. And how many maximum keys? 25 nodes we have, sorry, times 4, that is number of keys in a single node, right? So this is for level 3. See, very easy, in a very easy, we are just solving the question, right? Now for the last level, that is 4. So how many maximum node we have? The maximum block pointer in the level 3, that is what? 25 times 5 is 125. So how many block pointer will be there now? So what should be the answer? It should be 125 times 5. No, actually, nothing. Why? Because we are on the leaf node now. And in the leaf node, we don't have the block pointers here. Right? Maximum key, okay, that is 125 times number in a single 4. And that's it. Right? So now you can find out what is the maximum what nodes in a B or B plus tree. That is add these all the values. So 156. 156 nodes are there. Maximum nodes actually. These many nodes you can have in a B or B plus tree of level 4. And in this one information, what information you get? If you add on the value all these, but you will get, I have already done, that is 624 keys in your B tree, remember. B tree of level 4. For B plus tree, how many key values will be there? Maximum key. Again, for B plus, the answer is not same, 624. For B plus tree, we know the answer lie in this one, or say the key lies where? In the leaf node. Right, in the very last leaf node, we have the key and the record values. Right, so that's why this last level, all the maximum keys which are present in the last level will be for B plus tree. That is what 540, 42, 0 and 4115. That is 500 keys in B plus tree of 4 level. Right, so this is the answer here. So you see how easily you can calculate. And if you go to the graphical way of this one, so probably definitely you're going to confuse over here. So this is the way, and see the question can be, any maximum block pointers that you have. Let's say they can ask you what are the maximum number of nodes in level 3, right? Maximum number of keys in level 3. They can ask you any question. They see multiple questions can be framed in this one, right? So this is the way how we solve these type of questions. And see, these type of questions are very logical, right? So definitely if you will not go through this type of question, it will be very difficult for you to answer such questions. You're going to waste a lot of time. Once you have practice, you can solve these questions in a hardly 30 seconds, 1 minute, right? And you will find out these such type of questions are not solved where you can just find out any platform or something like that. Even in the books you won't be finding such type of solutions for the questions over here. It's very difficult, right? Just there are different variations are possible in such type of questions also. You need to know that also, right? Because concept you have understood, one concept you have understood, but you will not go through different variations, I mean to say different, they will provide you values in different way. So that is also you need to understand how you will face such type of question. The way of answering will remain the same, but those questions you definitely need to know how we will solve that. For example, if I talk about, the question will be something like this: how many minimum, let's say now minimum key, or say the nodes they can ask you, right, in B or B plus tree, when order is given, order equals to 5, order let's say p is equals to 5 and 4 level again. But assume now, this is important, the order is important. Assume says that order p is, see, understand how I'm writing, 2 to p block pointer for root, and p by 2 to seal value to p block pointer for others. You might find it difficult for the first time, right? So this is the question. They will ask you how many minimum keys are possible, right? Or assume, we need to assume, see, minimum is set. So you tell me, just think, we are given the value in the range of order, means what? For root node, you can have starting from minimum 2 root node till the order of p, whatever the order of p is, that is your for root node, right? And this, see this p is what? This is actually given p is equals to 5 over here. That is block pointer, means minimum you can have 2 block pointer in the root node, or maximum you can have the how many block pointer, how many as the number given equals to 5 in your root node. The second says that for the rest of the node other than the root node, how many minimum, see, block pointer that you can have in any node, that is p by 2c till maximum value p. This is what we need to understand, right? So how we will solve the question? Again, make the table and see how we reach to the answer in this way. This is the, I mean, the final one. I mean, if you understand this question, probably you can answer any question or like that, right? Again, we'll move on to what? Levels here. Now we need to find out the minimum, right? Minimum key. So we write first minimum node first. Then we find out minimum block pointer and then minimum number of keys, right? So at the first level, again, pay attention, focus. At the first level, how many minimum nodes are possible? Again, as I told you, minimum or say the maximum will remain the same as 1, right? Now, minimum block pointer. Now see this condition given. When you have the order P, your range of your block pointer, see this is what block pointer. Again, this value could be either your key value, right? It is block pointer, as I said. And remember one thing, just try this thing in such type of question. Focus on the order, what order is given, say what information order is given to you. That is very important, right? Because entire question answer depends on that order only. It says that the minimum block pointer, so we have, when we order P is there, minimum block pointer is 2 in this case, right? So straightforward, 2 is the value over here. If we have the minimum 2 block pointer, then how many keys are possible? Formula, that is 2 minus 1 equals to 1. So this will be the scenario for first level. Just let me know if you need to understand this once again. I'm going to repeat again from the starting. Understood, right? Okay. Let's start with the level 2 now. What values will be having at level 2, right? Again, for the level 2, the minimum number of nodes will be equals to the minimum block pointer in the first level. That is what 2. So same pattern, right? Now move to this one. So for level 2, how many minimum block pointers are there? Information is given for the block pointer, isn't it? Right. So whenever we need to take the value of block pointer, we need to get the value from here. We will get values here. So it says the minimum block pointer for the second level. So is the second level nodes are root node? No, these are false in the other section, right? So for this section, the minimum value is P by 2 seal, right? So that value will be how many nodes are there? 2 nodes are already there here. 2 nodes times P by 2. P is what? 5. So that is what? 5 by 2 seal value. And 5 by 2 seal value is equals to 3, right? So we have 2 times 3 over here. Okay, let me just 2 times 3. Okay, so it means 6 minimum block pointers are possible. Again, I'm repeating. For level second, we have 2 minimum nodes. Why? Minimum nodes equals to the minimum block pointer we have in the previous level, that is 2. So we have 2 minimum nodes. How many minimum block pointer? We need to find the block pointers here, and that is what the information given here. Since level 2 nodes are not root nodes, we'll go to the other section. And for others, we have the minimum value P by 2 seal, right? So find the seal value of P ratio 2, and that is what? 2 means 2 already nodes are there times P by 2, that is 5 by 2 seal equals to 2 times 3. So minimum key values, what will the key values of minimum? That is 2 nodes we already have. How many keys will be there in every node in this case? Again, that is what? 2 over here, right? So just think of why it's 2. 2 minimum keys are there. From where this 2 came? You can say that it should be 1 over here, isn't it? No. See, understand. These nodes are what falls under other part. Other category section says that how many block pointers you can have if the node is not root node, that is P by 2 seal. And this value is equals to what? P by 2 seal equals to what? 5 by 2 seal, that is equals to 3. So other than the node which is other than the root node will have minimum 3 block pointer. So what will be the minimum key value? 3 minus 1, that is 2. So this 2 is here, from here. And this 2 is for the minimum number of nodes that we have, right? So answer is 2 times 2. Hope you understood. Let's move on to the third level. How many nodes we have? Again, same, the minimum block pointers, that is 3 times 2, 6. So what should be the value of minimum block pointer? that is 6 nodes times again seal value 5 by 2, that is 3. Right, simple. And how many minimum key? That is 6 times how many? 2. Again, for the last final, we have 6 times 3. Again, it's last level, so no block pointer, only leaf we have. And for this one, we have 18 nodes times 2. And this is, that's it for level 4. So if you, they will ask you what is the minimum nodes are possible in B or B plus tree. What should be the answer? Just add on. What should be the answer? 3, 9, and 27. 27 minimum nodes. Right. And for this one, what should be the minimum key in B tree? So for B tree minimum key, add on the this one. Right. So 36, 12, and 5, that is 53. So 53 minimum key in B tree of level 4. And for B plus tree, last one, that is this 36 in B plus. So this is the other type of question where they will not give you direct values of order, rather they will give you in the range. So the homework for you is just for practice, instead of find the minimum key, find out the maximum. Right? Find out the maximum key or nodes possible in B and B plus tree. Okay. And also, in reference to this question that I have given you, try to solve this question also. Again, for practice. This is important. Right. The question is how many, this time again, minimum, uh, okay, you can say minimum, okay, find out minimum as well as maximum also in this case. Minimum and the maximum keys in B as well as B plus tree. See now, 4 cases with, I say order equals to 5 and level equals to 4. But order P is again defined. Assume order P is what? 1 to 2P. That is key for root. Again, what is given here? Just pay attention. And for P to 2P again, key for other node. You need to find out. Right. So make one table for minimum and make one table for maximum over here. Right. So see, in this one again, I you just need to focus on the value, or say the information about the order is given. So this order equal to 5 says about the key, not the block pointer. Right. So if you have the 5 as an order, say 5 as a order for your key, then what should be the value for your block pointer? That is one more, 5 plus 1, that is 6 block pointer will be there. So when you make the table, in the between you have minimum or say maximum block pointer, you have to assume 6 there, not 5. That is the difference. Right. So if you make table for minimum, consider these values. If you take table for maximum, consider these values. And you can just let me know how many nodes are there, maximum keys are there. Right. So keys are being asked, key in your this situation. So with this one, we say completely we have finished your BNB plus tree, along with a lot of good examples that are generally used to ask in your exams. In the next video I'm going to upload that's about your bulk loading in B plus tree, and that's a very small topic and a small video that you're going to find out soon. So in the meanwhile, just let me know if you have any issue. Probably you can solve these questions, and if you found something difficult in solving, then just let me know. So that is for today, and yeah, we'll see you in the next few videos as well till the course completion. Thank you all.